All right, we're going to go through this and hopefully will help you get ready for your test this week. This is our quiz. I'm going to go through and check our answers. So we got a question here that says, what is the acceleration of the car during this 4-second interval? So if we write out everything we've got 12 meters per second east. That's our initial velocity because that's what it said. It slows to 2 meters per second east in 4 seconds, which is our time. And then it's asking for what is our acceleration. Our formula for acceleration is change in velocity over time. If we plug everything in, our final velocity is 2. Our beginning velocity is 12. Our change in time is 4 seconds. So it's going to get us basically negative 10 over 4, which is negative 2.5. In this case, if the acceleration of the car is negative 2.5, it's going to the east and it's actually decelerating. So apologies. So since it is decelerating and it was going east, this ends up being an acceleration of 2.5 meters per second in the west because it's pushing against it and slowing it down. So again, direction matters with acceleration. Since the car is moving to the east, if this was accelerating to the east, it would be getting faster. It's actually accelerating to the west, so that's going to cause it to end up getting slower. All right, let me to the next one. All right. Main thing with these graphs, first thing, look at the y-axis. So in this case, we've got velocity. So this is a graph telling me how fast I am going. And so since the question is asking what's the velocity at 4 seconds, that's literally what the graph is showing me. So at 4 seconds, I go up to the line and then I want to see how fast it's going. I just move over here and it's going 8 meters per second. I mean, that is the answer to what we've got right here. So at 4 seconds, we're going 8, and that's the answer. That's all that we have to do on that one. The third one, we've got a velocity time graph to match up with a position time graph. So if we interpret the position time graph, let's think about what's going on. We've got someone moving forward at a constant speed. They stop, and then they move forward at a constant speed. So if we turn that into velocity, that means we've got a positive speed in the first part. We're stopped, so we're going to 0 in the second part, and then we've got a positive velocity in the third one. If you look at these, we could eliminate D because in section 2, D is still moving. And up here, the flat line on this graph means that it's stopped. And additionally, this slope is 30 over 1. So that should be a speed of 30. So that's going to eliminate A, and it's going to eliminate B because B would be going backwards. So the correct answer on this one's C, because again, in this first section, it's going 30 meters per second. The second section, it's not moving at all. And then the third section, it's going from 30 to 40. So it's going up 10 and over 1. So it's got a speed of 10. So this one should be C. This one's a reverse. In this first section, it's going 20 meters per second. And then it's going to be going negative 20 meters per second. These are basically the same speed, but they're in opposite directions. So we're looking for a graph that would go up first and then come back down. B is the one that we've got here. Again, B, the first section goes 40, we're going 40 yards in 2 seconds. So that's the speed of 20, which is what is illustrated by this one again, because this graph at the top is what the velocity is. This next one is a question about how long did something travel? How long is the unit of time? And so we want to know how long did it take for something to travel at 10 meters per second. So 10 meters per second is the section from right here. This started at 5 seconds. It ended at 10 seconds. So the time frame from 5 seconds to 10 seconds is simply 5 seconds. We're just interpreting the graph on this one. So next question is saying how far did it travel between points B and C? So how far it is distance. And distance is speed times time. And so the graph is showing us from this section right here that from B to C, the velocity is 10. And in the previous question, we looked at the amount of time it takes. It went from 5 seconds to 10 seconds. So this was a 5-second interval of time passing. So it's going to be 10 times 5. And the answer on that one should have been 50. So again, if you're asked to calculate the amount of distance that's traveled on a graph, we're going to have to use a formula for distance, which is speed times time, and then interpret the graph accordingly. This one said how many line segments was the object not moving? Again, if we look at the graph, the velocity is the y-axis. So the only line segment where it's going to be not moving is when the velocity is 0. And that's just going to be D to E. That is the only line segment where it is not moving. B to C is moving 10 meters per second. F to G, it is moving 5 meters per second. Need to look at the graph to be able to interpret it. This next one, Human Runner, has an average acceleration. Again, we want to write down the things that we know. We've got an acceleration of 1.2. We've got a time, which is 21 seconds. We're looking for a change in velocity. And that's what we don't know. Acceleration is change in velocity over change in time. The change in velocity, we don't know. The time was 21. And then that needs to equal 1.2. So if we multiply both sides by 21, we're going to get the answer for that to get 21 out of the bottom fraction. So 21 times 1.2 is going to give us 25.2. Again, multiply both sides by 21. That's going to cancel the 21 out here, give us 25.2. And this should be in, since we're talking about a velocity, meters per second. And it doesn't describe a direction, so we can just leave it at that. By definition, acceleration, just the previous one, was a change in velocity over a change in time. The answer is this third one right here. It's the change in velocity divided by change in time. This next one, we're looking for an acceleration again. Acceleration is change in velocity divided by change in time. 20 meters per second is our initial velocity. Accelerates for 5 seconds, that's our time, to a final speed of 50 meters per second. All right, so again, acceleration, change in velocity over time. We ended at 50 and we started at 20, and that took 5 seconds. So it's 30 over 5. And we should get 6 meters per second squared. Again, it doesn't really give us a direction, so leave it at that. This graph, we're comparing accelerations. Again, with a line graph, acceleration is the slope. So if I compare the slopes, I can compare the acceleration. So for B, to get the slope, take 2 endpoints. How far up did I go? I went up 10. How far over did I go? I went 4. The acceleration is 2.5. If I do line A, then again, I go up 20 and over. Well, it's hard to see on this one, so I could probably better pick that point because it's on the line. So I can go up 15 and over 2. That is 7.5. And if we're comparing them, 7.5 is 3 times bigger than 2.5. If you divide 7.5 by 2.5, you get 3. So the acceleration of A is 3 times as large as the acceleration of B. This question is asking, in which section of the graph is the average velocity the greatest? Again, if you're looking at the graph, the velocity simply is how high the graph is. And it was this line right here between C and D when the velocity is going to be the greatest, because from C to D, it was going 30 meters per second. At no other point in the graph was it even going greater than 30 meters per second. So this would have to be the greatest velocity. If we have a positive acceleration, that means we're speeding up. The only one that we've got that's speeding up is graph C, because over time the speed goes up. By definition, that's what acceleration is. Car is not moving forward. So in graph A, the car is moving forward because it's just slowing down. Graph C, it's moving forward because it's speeding up. Graph D, it's moving forward because its distance is increasing over time. And it's graph B, in which the distance is not changing. So again, read the y-axis. This was a little bit of a difficult one. It said, how far did car B travel during the time shown on the graph? Same principle we had on an earlier question, though. The distance is speed times time. In this case, car B was going the same speed the entire time, which was 30 meters per second. The amount of time was 7 seconds. So it went 210 meters during that time. So again, distance equals speed times time. Acceleration is a change in velocity or a change in direction. Excuse me. So effectively, it's a change in velocity, which includes speed and direction. So we've got 3 accelerations on here. If I turn the corner, you're accelerating because you're changing direction. If we're going down a hill, we should be changing our speed. And if a skateboard comes to a sudden stop, it's also accelerating, it's decelerating. The balloon traveling like this, that's just the speed. A bird flying 10 miles per hour, meters per hour south is the velocity. And again, if something's sliding to the left at 5 meters per second, that's a velocity. The other ones are accelerations because they are either changing speed or direction, which means their velocity is changing. One more in here. Okay, this is a similar graph to one just a moment ago, but this one's a little bit more complicated because it's basically got 2 pieces to it. You have to figure out how far does it go in each section. And our problem here is that this one goes from 0 to 60, but you do have a formula about the average velocity. So again, if you take the speed times time, that's going to give us distance. And this is actually the average speed. So between 0 and 6 seconds, the car goes from 0 to 60. So the average velocity is the final velocity and the initial velocity added together divided by 2. So in this case, it's 0 plus 60 divided by 2. So the average speed during this line segment is 30. So during this segment, it was averaging 30 meters per second, and it took 6 seconds. So 30 times 6, it would have covered 180 meters during this part. This last little section, again, speed times time. It was going 60, and it only went for 1 second. So it went 60, it was going 60 meters per second. It did that for 1 second. That's another 60. So if we add these 2 pieces together, 180 plus 60 in the first segment, we would end up with 240. So that was probably the hardest question that was on there. But again, we're using our formulas that are available to us to be able to answer those.